Good afternoon. Welcome back to our chemical equilibrium acid basis, and today we will see the solubility and how some salts are highly soluble, some are very low soluble. What is actually the reason? We will try to find in small way. So some salts are some highly soluble, some salts. What is that highly soluble or medium soluble or insoluble? What is the basis? Highly soluble means highly soluble. Criteria is if it is solubility is more than the 0.1 molar. Solubility is more than 0.1 molar. This is called highly soluble. That is the category. Then medium solubility. Medium solubility. Solubility is in between. It is more than the 0.01 and less than no, it is more than 0.01 and less than 0.1. That means in between. That is in between 0.01 to 0.1. That is the medium soluble. Insoluble. Insoluble is less than 0.01 molar, all molars only. This is the criteria. Normally in the chemistry people will say or follow the conventional methods for the international. Highly soluble, the solubility is more than 0.1 molar. Medium soluble, it should be in between 0.1 to 0.01. Insoluble is less than 0.1. Okay. Now, why these things happens? Why some are highly soluble, while some are medium, some are insoluble? There are two factors affecting the solubility. There are two factors. Factor 1. Factor 1 is the lattice enthalpy. Lattice enthalpy. Number 2 fellow is solvation. See, meaning is solvation enthalpy. The meaning is a crystal is in the lattice form. Salt is in the lattice form. So that lattice energy should be overcome by the solvation. Means when it is added in the solvent, when the salt is added in the solvent has to break the lattice enthalpy. That means solvation enthalpy should be always more than the lattice enthalpy. Then only the more the energy, the more the solubility it will be. So these two are the factors, which is the lattice enthalpy and solvation enthalpy. So when it is more than the solvation enthalpy is much more than the lattice enthalpy, it is more soluble than otherwise in medium. If it is very less, it will be this is a positive. That means energy will be released. This will be energy is consumed. That is the criteria, right? Then what is the solubility product? How the solubility is representing and all this 0.1 molars and all this thing, how it is. Take a salt of the barium sulfate. Barium sulfate is in water, that is in supersaturated with the barium sulfate has formed. Barium plus 2 plus 4 minus 2. Now, as usual, our equilibrium constant equal to barium plus 2 into sulfate minus 4 by anyway barium sulfate water. We need not to write also. We will write first. Afterwards we will remove. So need not to write because it is taken as a 1. So it is the solubility of this both. That means it is the solubility product. So K will be represented as the KSP, solubility product. So K is represented as the K. So now how much is the barium sulfate? How much is the concentration of barium? Because it is equal when it is the 1, it is 0 initial concentrations. When it is after some data equilibrium, it is 1 minus x, means it will be the x and x normally it will be. So x square. So x square will be the solubility product by 1 minus x. So finally, if you are seeing the barium sulfate, the practically KSP is taken as the 1 into 10 to the power of minus 10. 1.1 into. So that is nothing but x square. So barium solubility will be the solubility what how 1.05 into, that is the root, under root of this one, 10 to the power of minus 5. So okay, if it is only the two ions, if it is in the water, then it is very simple, easy, and all these things. Suppose if it is a very large number of zirconium, suppose zirconium phosphate, ZrPO4 taken 4 like this ions, then how this solubility will be, and if you see this fellow, this will be the very big root under all, this will be like this zirconium, that will be as a 3 and plus 4 phosphate and zirconium 3. So the KSP will be zirconium 3 zirconium and 3x into whole cube into 4 PO4 into 4 concentrations. PO4 means it is a 4. All together will be the under root of 3 plus 4, 7. So finally the each individual will be KSP by, if you see the one x equal to how much, that multiplications and all these things, KSP by some 6912 to the power of under root 7, like this, it will be the big number. So finally what you have to do, it is not easy like a two components and all. If it is a multiple components and all, carefully one has to do. So tomorrow we'll see the common effects and all. Tomorrow, today some more small the pH immediately offline or 1 minute or less than 1 minute calculations of the pH we will see in a minute. Suppose pH of the point 10 to the power of 10 to the power minus 3 HCl concentration, pH how much? Immediately you can say minus log H plus, and the pH equal to 3. Minus log H plus concentration you have to take minus log H plus concentration equal to pH equal to minus log H plus concentration. So pH 10 to the power minus it should be 3, right, for HCl in the case of. Suppose the same thing is given for sulfuric acid. Now it is not that easy to say pH how much for 10% sulfuric acid. It is not the double, or it is not the same as 3. How? Here H2 2 times it will be the H plus will be released. That means sulfuric acid will be like this. H2SO4 gives 2H plus plus SO4 minus 2. Not like that HCl equal to H plus plus Cl minus. Not like this. So 2H. So here what will happen if you want to do and then oral calculations and all. So here it will be 10 to the power minus 3 only, but it's 2 times. That means 2 into H plus concentration will be 2 into 10 to the power minus 3. That means it will be the minus log 10 power minus 3, 2 into 10 power minus 3. That value will be 3 minus log 2, that equal to some 2.7. Log 2 equal to 0.3 normally. So like this pH will be the not same for the single H plus and the same thing. So similar cases, if you see for the NaOH, suppose if it is say 0.001 normal or NaOH pH and the calcium hydroxide pH, both will not be the same. Here the OH will be the double, here OH will be the single, and here pH calculation will be the volta. Volta means it is 0.001 here. That means the concentration of NaOH will be 1 into 10 power minus 3 normality molar concentration of NaOH. So here what will be the pOH? pOH will be 3. That means pH will be 14 minus 3 equal to 11. So slightly one more step will be added in case of the alkali pH if they are asking. pOH will be the 3 and pH will be the 11 in case of NaOH. The same thing if this is 0.01 calcium hydroxide, if it is asked, what will happen? It will be the double. That means it is 10 to the power of minus 2 the calcium, OH concentration will be 2 into 10 power minus 2. That means the OH itself is POH itself is 2 minus log 2. That is nothing but 2 minus log 2. POH equal to 2 minus 2 plus 2 plus 2. It will be the 2 point log 2 equal to 0.3. So if you are minusing 14 minus 3 plus 0.3 to 2 minus 0.3, that is nothing but 12.3 the POH. So calculations will be the double for the calcium hydroxide, or in case of anything like 3 times and all these things, please calculate very fast but more carefully. Tomorrow we will see some more problems and the typical problems, and thank you.